All right, this is the online video for IT 201. This is the week after spring break. The live lecture had to deal with the basics of animation, using the animation window, the animator window, talking about what animations are, this change of data or values over time. Very similar to how you kind of exposed variables through the inspector, and then you were able to manipulate them, or how you expose them through the user interface and the user can. Now we're going to expose them to this animator so that we can control this variables over time. And we had, if I click play, we had made some, for example, this one is just a square, or a cube, I should say, that is just changing its color values and it's changing its size values. So if I just turn off the time destroy, yeah, it's a very dynamic stroke. Now we can talk about animation or creating information changes over time. But notice that the animation system, one issue I said is that you can only manipulate one parameter with either code or animation system. So the animation system, if you strip it away, it's being controlling stuff with code, but it's a designer oriented, a kind of removes the aspect of actually coding the data change over time. You can kind of do it as a designer perspective. But these tools do come with a limitation that you're interacting with this variable, this data, with the animation system, and as such you cannot interact with it with code. So my size slider does not work because it's calling a method. That method is trying to change the size of this stroke, these painted objects that exist, but it's not allowing it. But if I shrink down the size, yeah, it's being overwritten no matter what. So one aspect is that's fine, you know, like these animations are great. There's multiple animations, you can transition between them. They still do offer a lot to interactive design. But if you're really happy, use the animation kind of window to design these time-based data changes. And if you really like them and you want to make them more dynamic to your user, the next stage is processing that information over, pulling the information from the animation window, and then redoing that in a code situation. So if I open up, so you go to here, click on one of these. This is the animation. These are just values that are changing. And it looks like they're just on the scale and on the color. I can actually change these values over this amount of time and just repeat this animation with code. Now that I know at what point should the values change. So over a period of a second, you know, 1/3 in, the scale should go from 1 to 0.5 or whatever. And I'll show you some built-in methods that help with this situation. So I'm going to dock this animation window down here. I'm also going to talk about some UI changes I did to make things a little easier to handle. Some UI updates for Sprint 3. And if I clear out this paint stroke, and if I use this one, here's a new type of, somebody had asked for, oh, what if I have a prefab that has multiple objects in it, and I don't want all the objects to be parented to one, to be, get influence, inherit their position, scale, rotation information. So for example, if I clear that out, switch to this one, this was a previous one we made. Notice how the spheres are children of the cube, and so there's a cube and a sphere for each paint stroke, and the sphere is being manipulated or controlled. It's by the scaling that's happening to the cube. So sometimes you want that, and sometimes we'll create, in this case, these are like sibling objects. They're allowed to have their own animations. They're not inheriting from each other. So I'm going to cover that in this class too. So what you want to get to at the end of this week is that you're comfortable creating an animator, attaching it to your prefab, and creating an animation, a change of values over time, and that you can that everything works in a way that when you instantiate the prefab, the animation plays. Later on, we might do multiple animations. We might transfer animations over to straight code, make things more elaborate. But if this week you can do that, you can create an animated prefab, then you know that you're on the right track. And in class on Monday, what I'll do is I'll cover more details of the project deliverables, but just know that this sprint 3 is going to be very similar in structure to sprint 1 and 2, where you're going to write your own project description, you're going to define your user flows, and you're going to code up and then build a WebGL project. This sprint 3 is focused heavily on animation, understanding the animator and the animation windows, creating your own animations, and then building your own WebGL project. And I will, next week I'll build out my project, I'll scope out my user flows, but now there's even less structure. I'll leave it at that. Like the first sprint, you were allowed to use up all my user flows, and then the second sprint, I showed you 4 user flows, and I wanted you to make 5, meaning 1 all by yourself. Now in this sprint, we'll probably do like half and half. Maybe I'll show you 2 or 3, and maybe I'll ask for like 5 user features related to animation. Also, this sprint is more, we will return, we'll be using code, but it's not 100% coding as the other sprints, because now we're kind of relying on this animation system to help us with these new types of information, this time-based information. So, with that all being said, let me clear this out, and let me show you that now, when I resize my game window, no matter how I do it, my UI stays perfect. So I decided to switch my UI over to world space. I'm going to show you how to do that, so that now you don't have to worry about things repositioning, this and that. What you see is what you get, exactly. So we're going to have to do some tweaks to the user interface, and what it does is if I zoom out, it actually exists in world space. It's not like super large and off to the side. So if I turn on the old canvas, notice it's like really big, it's off to the side, it's not in our main view, and it just gets cast to the camera within screen space. Here it lives in world space, and so as I move this back and forth, it's exactly where it's positioned because it lives in the world. It doesn't matter how the screen space gets adjusted for how big this frame is that'll be rendered to the web browser. So a few parts. One, there's a quad sitting here, and there's nothing on it but just a shader, and it's an unlit shader. And the reason for that is no matter where the sun is, no matter how dark it is, I just want it to be the same color. All right, so that's just a material. You can go right click, create material, and it happens, I just called it light gray, you call it what you want, but go to shader, unlit color. Very similar to how I redid the materials on the clock. I redid this material so that it's not impacted by the light source, and then you can just add what color you want. I just did a kind of dimmer brown gray, nothing to stand out, spectacular, take your eye away from what you're doing. And I positioned it. If you look around here, it's sitting behind. So now I'm kind of thinking about the layering of information. This is the background to my little user interface. So it sits behind the clock. And notice how my user interface elements all line up in the same depth. Don't mess around with the Z values on the user interface elements. So we got the clock. And if I move a little bit, notice how the AM button sits right in front of the clock, so it's rendered on top. And I positioned this little quad, I just moved it and scaled it so that it kind of sits nicely. There's just a little bit of margin room around it where it feels like it's the background for the user interface. There's a little bit of edging, a little bit of border space, kind of buffers out the little UI elements nicely. The clock sits in the center at the top. The little AM button sits right in the middle. And I redid my my title space information, so it's nice and tight and it fits within this space. So it's just my name, the class, the section. I don't even say section anymore. Just kind of, this is a class, this is a section. We're in sprint 2. Paint is left click, erase is right click. Really simple, straight to the point. People don't like to read a lot of information on the computer, so just give those straight directions, right? Parts of my user interface are kind of aligned. This is all about the destruction. This is all about selecting your primitives, destruction too. This is about our slider areas for our paint stroke options, colors, glow, opacity, size. Everything's kind of organized well. I kind of refit stuff. Everything's bounded. And the mouse position, this thing, I kind of cleaned this up and pushed it in so that it fits around this information well. So the only thing I might consider doing, now they just painted right in front of this, is actually moving where we're painting to be behind this all. Because, oh, there we go, hit the clear button. Let me switch over to the smaller paint stroke. So what we have here is we've got the camera here, we got our paint strokes here, our user interface, and the 3D, even though this is a 3D object, it's sitting in this plane, I got my back plane. So let me continue talking about the user interface, but what I'll probably end up doing after, in the next week, I'm just going to write it down real quick, is the position of painted objects to be behind my UI. Then I don't have to worry about, remember how I was kind of checking how far should I be painting over? Like if I keep moving this paint stroke there, eventually I can't paint any further than here. And I was trying to figure that out based on the X position of the mouse. Well, if I paint the objects behind my little paint canvas, if the objects are being cast out here, I'll just move this real quick because I'm in play mode, it'll pop back. But if I move this and then move it over, notice how it's okay if the objects get painted behind it and they get drawn behind this object here, the canvas. So that's where I'm going to get to probably next week. For now, I'm going to talk about how I repositioned this user interface and how I made a few more of these animated strokes, and that'll be it for the online video. So I'm going to turn this off, turn back on canvas normal. So notice it's big, it's over to the side, and it's render mode, screen space overlay. So I'm going to duplicate it and do the same workflow again. I duplicated just in case I broke anything. So the original, I'm going to turn off and hide it. I'm going to call this Canvas World 02. I'm working with the duplicate so that if I really screw things up, I can just delete it and try again. First step, I am going to go to the render mode. I'm going from screen space overlay to world space. Now notice it disappeared from the camera. Now don't freak out because it's way off to the side here. It's actually not in a position in the world to be rendered to the camera. And that was on purpose because it gets cast into the screen space overlaid, but we're not doing that anymore. So first off, position zeroed out. We're going to center it up into the world, X and Y. I'm going to leave the width and height alone. The size of it is fine, but the scaling information I'm going to bring down. I'm going to scale it way down until it actually, and press the F key, keep scaling down, F key, scale it down, and you see I'm almost getting it into the camera view. Press the F key, and it's close enough. I'm going to leave it alone. So you see I scaled it down to almost like 2.5% what the original size was. So actually most of the work is pretty much done. I'll move it a little bit. You know, I already created this background image and resized it. And since this background quad, again, that's game object, 3D object quad if you need to create it from scratch. It's already kind of sitting in world space relative to the camera, and so is the clock. So luckily I had some other objects to orient the canvas around. And now it's scaled down, and then you can go in, and if you remember the tweaks I was talking about, if I turn on the other and just move this over a little bit, I repositioned the clock, the AM, PM icon. I cleaned up my title information. And as you can see, I didn't really mess around with these because I was already kind of organizing all these other 3D elements, or UI elements. But I kind of cleaned up and shortened this mouse position. So anyway, these are kind of little cleaning, housekeeping, just nice clean UI situation. I'll leave that alone. You can just go into each one, adjust their width, their height, or their position. But at the end of the day, I'm just going to delete it and go back to my original. And that's how I got to this. So I just zeroed out the position, reduced the scale, and then put the elements where they needed to be and reposition, rescale, reorganize them. Now, once you're done with that, all the scripts that are on the buttons on this new canvas will remain the same. They're still calling stuff on our click position manager. That's fine. But on our click detector, our click position manager, that was referencing our text elements in our UI. So if you clicked play and ran it, you would see that certain parts like this, the text isn't going to update. The mouse position is not going to update. The numbers on our red, green, blue, these numbers are not going to update. So this text blue, text red, text green, this text mouse position, text timer, which is if it's 1 to 5 second, all that is on the click position manager is connected to our old canvas, our old UI element. So if you did not, duplicate it and hide the original, yeah, your reference connections are fine. But I wasn't sure what I was going to do to the user interface, if I was going to damage it or not. So I decided to hide the original and play with the duplicate. So to reconnect the scripts, you have to open them back up and find stuff. So for example, color sliders. If I open it up, here's text red. I gotta just make sure it's referencing the text red that's on my new user interface. Green, there's green. Blue, I gotta go down, here's text mouse position, connect it there. Somehow I gotta find my size slider, there you go. And there's the text for that. Oh, I'm actually not connected to it. That was an old one, I didn't actually need that. Because I'm not dynamically showing my size information right now. And the timer, right? So the timer is under here, timer, text timer. So notice now that I spent the time to organize everything and label them correctly. It was very simple for me to reconnect my references. So again, click play, test that everything works well. So if I just wait a second, there we go. So just do some initial user flows, test everything works well, that's great. Move the slider, yes, the numbers are updated and timer numbers, the mouse position's working, the numbers on red work, and the red slider works, the numbers on green work, numbers on blue. So we're good. So I retested my new canvas, everything's connected. And the benefit of this now is that it's perfectly showing and keeping UI elements where they are, no matter the size of our display. Remember now, my game view has this aspect ratio, 960 by 600, which is our WebGL build. So that's why I'm getting cuts here. This is the aspect ratio. No matter the size I move, it must maintain whatever 960 width by 600 height, whatever that aspect ratio is, it's keeping that. And my UI is keeping in place because it's now in world space. Great. So now the next topic are the paint strokes, the animated paint strokes. So let me see here. I'm going to go over to project, prefabs. So let me quickly recap how we created this one. So click detector, okay, cube animated. So I'm just going to bring it out into scene, reset the position so it's at world space 0. Now this was just a cube, and all I did was create the animator. I went through how to create the animation folder, how to create animators and animations. Oops, it's a little off the viewing range. I'm just going to lift it up. Still, wow. I'm just going to use this. It's the same menus up here. I just want to show you. Create. Here's the animator. Here's the animation. All right. So this cube, named it something new so I know what it is. And I'm going to open up the animator window. It's the animation window. Perfect. So the animator has one state. That one state is our animation cube bounce. And if I go over here, I can click play to sample it, what it looks like on one paint stroke. It's just morphing the scale in different ways on X, Y, and Z, and it's just messing with the color values. And if I just want to look at the scale, I can press the F key and look at the curves of what X, Y, and Z are doing. And then if I want to look at the colors, I can click on that, press the F key. This is what the color information is changing over time. Horizontal is our time value. We're going from 0 to 2 seconds, 60 frames a second. Each frame is a change of visual information. And on the vertical is our values that are being changed. So for example, green is going from 0 to 1 to 0. And if I press F key, it looks like our everything starts at 1 for scale. Looks like some are going down to close to 0, some's going up to 2, and then we're back to 1 to create that looping animation. Great. When you're really happy with it, you click apply, what have you. And you can just delete that instance because it is right here. And you have to remember that you have to connect it. I have 2 click detectors. That's not good. I'm going to delete that. So what you're spawning, painted object 1, 0, 1, 2, you have to remember to connect these new ones to it. And probably my dropdown should really be updated as well. So dropdown, primitive, where I'm not really messing with spheres, cubes, and cylinders. This is a cube. And the second one I connected is like multi-cube, I called it. So let me click play and see what those changes look like. So there's the cube paint stroke, right? And multi-cube is what multi-cube looks like. And I'll keep cylinder for now because I'm going to make one. So notice that I can open up the width of this drop down. These characters are getting kind of long, but for me that's fine right now. I actually do kind of have the space for it, so why don't I open up this, move it a little bit, now I got to take that clear button, move him over, there we go. Click play, and there multi-cube is fully spelled out. Great, so let's talk about how I made this one, which leads me into some student questions of multiple objects are cool, but I don't want this inheritance situation. So objects underneath it inheriting the transform changes. So I got this multi-cube here. I'll drag this in. I'll just reset it. So what do we have here? All right, let me move it over to the side and I'll recreate it. So we start with game object, create empty. We're going to zero out the position. All right, it's just an empty, it's going to be a holder. I'll call it multi-cubes 02. Now it's this is the object that's going to have the animator on it. And underneath, we can control objects. All right, so whatever objects you want. Let's say in this case, you know, I'm going to call it, this is going to be my, my new one. I'm going to call it just cylinders, or multi-cylinders. All right, I already made multi-cube. Let's make multi-cylinders. So 3D, I'm going to create a cylinder. I think I'm going to go with a capsule because it has a rounded top and bottom. Oops. Yeah. So I'm going to zero it out, and I'm going to drag it underneath our parent object, and then do what you will with it. Say, all right, maybe it's too broad. I'm going to just make it a little skinnier. Something like this might work. I'm using this as a reference. Okay, so 0.5. And I'm just cleaning up the numbers. It's easier to deal with. So, all right, that's great. I'm going to duplicate it. And I'm going to rotate it. Looks like maybe -45. And I'm going to duplicate it again and do 45. So I want to see what it looks like. Sure. All right. So we have this object. Capsule 1, 2. So I can rename them. Maybe capsule center. Rename this one to capsule... I'll just say right because its top part is right. It's a quick way to reference the difference between them. This will be capsule left because its top part is on the left side. Great. I've got 3 objects under a parent. I'm going to go ahead and just assign some materials because I know I'll be changing those or assigning those with code. So I think the one I was using was just, yeah, it's called painted. Wait, I gotta click off them. Painted. All right, let me zoom in. I've got this because I think I have other stuff at world space 0. No, I'm just gonna click right on capsule right. That's weird. I'm going to try dragging on the object name here. All right, that was a quick way. I'm going to assign them. For some reason, I think it's because it's sitting at world space center. Let me move it off to the side, off of everything else. And let me try dragging this on. No. Let me try it again. I thought in the scene view you can... They're acting a little finicky for some reason. Usually I'm assuming you can assign stuff through the scene view, but anyway, I'll just assign it here in the inspector and move this back to world space 0. Sorry, there are 3 objects. We have this standard shader material. It just happens to have some random color and emission assigned to it and some transparency. This is the shader we're using on the others to randomly assign amount of transparency, emission, and diffuse information, or basic color. So that's all set up. Now we have to create an animator. Create, since it's coming off, I just clicked on animator controller. It was in the list. I'm going to call this multi-cylinders. Okay, so we have our animator. I can assign it to the parent object at the top of all the capsules. When I do that, click over to animation and say, hey, to begin animating this object, because we haven't clicked, that's great. Click create. Go to the animation window. We're going to call it, I guess, multi-cylinders, and then whatever the name. Sometimes I continue camel case, sometimes underscore it to separate it from the name. Looks like I'm not underscoring the rest, so I'll leave it like that. And then I'll call it movement. That's like seems to be the animation I was going with the multi-cube, so I'll just follow that. When I click add properties, yeah, I can animate the transform on the parent, and I'll show you real quick. I'll just do that, sure. I'll do like a change in the scaling information, and click play. And notice all 3 objects are inheriting that change in the scaling information because they're children of this parent object, even though the parent object doesn't contain any rendering or meshes directly on it. The children do. So I'm going to stop that, and they're inheriting the animation. I'm actually going to remove that because at this level, the most root level of our prefab, I'm actually controlling with code. So that's how I'm controlling the scaling of it. So if I just click play, you're just going to have to ignore these two right here. If I move over to multi-cube, notice I can scale it because its children are being controlled by the animator, not the parent. So I can grab the parent scale, which is impacting the rest, with code. So leave the parent alone. You can grab that with code. Go down into the center. Say add property capsule center. And then I can mess with its scale. Capsule right. I can mess with its scale or rotation, or you can do whatever you want. Left. Scale. So I can open up the center and say, okay, let's bounce it. It looks like we've already scaled the X and Y. Maybe I can scale it, and then the left and right, maybe offset it a little bit, or to show that they are different, maybe I'll enlarge them. And this is the animation. They are indeed three separate objects doing different things. All right. Now, maybe on the parent, I can do a rotation because I'm not messing around with rotation by code. If you are, then you can do something else. But let's say, hey, I just want to rotate you. Let's see what it looks like. All right, I don't want to rotate on, I thought the Y was the right way, but I'm kind of trying to do, let's see if X was the right way. Almost. I think I meant to do Z then. Last of the three. Let's take a look. Yeah, that's kind of it, but I would like it to do a full, I'm trying to get it to do a full circle, and it's going from 0 to 180 and then back to 0. But if I go here to 360, I think I might be good. Nice. So now it's rotating 360 degrees and looping on that, and then they're doing this scaling up and down. So notice that the scaling, or the rotating, went from 0 to 180 to 360. And 360 is the same as 0. So even though the ending number here is different than the beginning, we're going from 0 to 360. And notice that there's a pop here. Actually, this middle key, I don't even need it. We're going from 0 to 360, and then it goes 0 to 360, 0 to 6. Those is a huge, pop, but we don't see it because 360 and 0 are the same thing. So we still get our loopable animation, and that's how to deal with full rotations in a loopable situation. So I just did sibling animation. I animated 3 siblings, and I even animated the parent. So now all 3 are rotating, even though I'm just rotating the parent. So you can see what it's like for children to inherit animation from its parent, and what it's like to animate the children or the siblings distinct from each other. So I'm done. Good job. I'm happy with this. I haven't made it a prefab yet. I'm going to drag it in. It is now a prefab, and so I can delete it. And I can actually delete these cubes over here. And let's actually connect it up. So we have cube animated, we have multi-cubes, and now we're going to have multi-cylinders. And I'm just going to update my drop-down list here so it actually shows, instead of cylinder, we're going to have multi-cylinders. Great. I'm going to click play. So there's the cube. Here's the multi-cube, which since I'm not messing around with the scaling on it of its parent, let me do multi-cylinder and you'll see this. I can actually adjust the size. I'm going to turn off destroy. And notice that these objects, I can manipulate their size. So I have to go into some script because I did change the script for dealing with these type of nested objects. So notice that the glow and the opacity, and I think that, yeah, the coloring aren't working. When you do new ones, it does, but the old ones you can't manipulate. So I'm going to have to deal with that next week, the coloring. But we just solved some issues with that. We can keep the size dynamic, and we can randomly influence the size as we paint it. And they're still using size controls on here. They're still scaling up and down with the animation. So now there's some code I have to go in. So basically the parent scaling, we can still manipulate. The children's scaling is controlled by animation. So there's this part of the code I did have to change. So in dealing with the prefabs we were dealing with earlier, the mesh renderer was right on one object. We just had one object. It was simple to deal with. This was how we did it. We did some random color. We assigned it to the color attribute of the material, of the renderer, of our prefab, of our instantiated prefab. But if you run it, you're going to get an error that says like, oh, couldn't find a mesh renderer. That's because the multi-cylinders, if I open this up, there is no renderer on this level. We have to dive down. Notice that here's the renderer. There's actually a shader on it. So the children have shaders now. The parent does not, or renderers, I should say. To accommodate that, we do a check. First, this was the original code. Wrap it in an if statement. Say if primitive.getComponentRenderer is not equal to null, actually add a color to it. So if the parent, so a prefab that's like this, cube animated, it has a mesh renderer on it, there's no children to it. At this root level of our prefab, there is a renderer that we can assign a random color to. That means awesome, go for it, assign it. If not, if the parent, the high level, the root level of the prefab does not have a renderer, skip this code. So if primitive.getComponentRenderer is not equal to null, actually assign a color to its renderer. Then, so we've taken care of the root level of our prefab, if whether or not we should generate color for it. We have to look down into its children. So for each transform child in primitive.transform, which we've dealt with down here, in this case we're looking at already existing transforms of existing paint strokes. Here we've just created one, and we can still have a reference to it because we just created it and we assigned this handle to it called primitive. Right? So we can look down into its transform. So when we instantiate, for in this case these multi-cylinders, here is the transform. Say we just instantiate it, I drag it in, here it is, I just painted it. We say look at its transform, is there children underneath it? Are there children game objects that we have to look at? If so, we're going to dive into each child and we're going to add a color to its render. So I didn't do a check within here. So if it gets even more complicated, I should probably even nest it. I should probably do a check. But before I add the check, let me just note that what we're saying for each, in the primitive, the current one we spawned, in its transform, if there's children, we go through and we create a random color, and then we assign it. But what's different here is it's the child dot game object, go from it the transform of the child up to its game object, find its render, assign, find its material, assign a color. Here we're taking the primitive reference, the root of the prefab, getting its render. Here we're getting its child. Go find its render because it's going to be different. That's how we assign random colors to all these different parts of the prefab. And then the same for the emission color. All right, so the only thing I should mention is that if there is, in my case, there was no children without a renderer, but I should check. If there's a child within this painted object that we just drew, if the painted object, if the child, one of these child game objects is painted object, check first that it has a renderer, meaning the reference is not null, that it is connected to something, then go ahead and give it a color and a emission color. So this was it for the code that I added to deal with prefabs that are beyond something like this, where it's just one object. If the prefab has multiple objects underneath the root, then you have to deal with all of their renderers separately in a for each loop, as you see here. So this is it for the code. This if statement up here, wrapping around a color and emission, and then for each, go check the children, and now do a check. Is there a render? If so, assign it to the child renderer, not the root renderer. All right, I think that's more than enough information for this week, so I'll leave you to it.